Hello friends. Before we get started with this explanation, I just want to mention that if you have any questions regarding this topic, please don't hesitate to leave them in the comments. We would be more than happy to assist you with any answers you may need. So in this video we will learn how to build a simple single BJT LED flasher circuit and also learn its circuit functioning. Making this circuit is very simple, and you will just need the following few components, and assemble as per the shown circuit diagram. Now let's understand how the circuit works. When we power the circuit with plus 12V, the capacitor C1 begins charging through R1. But since the transistor's base is left open, it has no direct bias path. Still, due to leakage current and internal junction capacitance, a tiny amount of charge builds up inside the transistor. At first, the transistor is completely off, so the LED remains dark. As the capacitor's voltage builds, a small displacement current passes through the collector base junction, and that microscopic current slowly raises the internal base potential. When the base emitter junction reaches around 0.6 volts from this internal buildup, the transistor suddenly conducts, like a self-primed trigger. The LED flashes on, drawing current through R2. The instant it turns on, the capacitor voltage collapses, because the transistor's internal capacitance and charge paths pull its junctions in the opposite direction. This sudden reversal pushes the transistor briefly into a negative resistance region, allowing the LED to turn off again as C1 recharges in reverse. This action repeats continuously, even though the base is floating. The transistor's own junction capacitance, leakage, and regenerative discharge action together form a natural oscillating loop. Why it still works, linked to negative resistance. This is exactly where Dick Kappels connected the behavior to Ryona Asaki's negative resistance theory. In a tunnel diode, electrons tunnel through the barrier and create a backward or negative resistance region. In this flasher, the transistor junctions momentarily act the same way, not by tunneling, but by charge storage and capacitive feedback. That's why even with the base left open, the circuit keeps oscillating, purely due to internal charge dynamics and the transistor's inherent negative resistance characteristics. So that concludes our explanation on our single transistor LED flasher circuit. If you found this video helpful, kindly give it a thumbs up, share it, and subscribe for additional electronics tutorials similar to this one. Thank you for watching.